Hello science family. Today we're going to be dealing with the foul water lab. If you take a look, this is some really dirty water. So this is going to be a mixture, but this is definitely a heterogeneous mixture. There's a bunch of different chunks in here, different colors. It's not a very nice mixture. So this is some dirty water. Now, we're going to take some observations, mention its physical properties, and we're going to slowly try to clean this water through something we call physical separation. So to do that, the first thing we need to do is kind of get our pulse on this liquid and see what it's like. If you look at your lab, we're going to be collecting data on its color, its clarity, its odor or its smell, if the presence of any oil, if we see any oil in it, and also if there's any solids. So some of these will be a yes/no answer, but we'll go through that. So the first thing I'm going to do here is I'm going to give this nasty water a shake, and I'm going to measure out, like the lab says, I'm going to try to get about 100 milliliters of this dirty water to start. So we're going to fill up our graduated cylinder. We're going to measure that and make sure that it's at 100 milliliters, which it is. Perfect. So, looking on your lab write-up in the data table, first thing we can do is we can start by saying that we have 100 milliliters of our foul water. Go ahead and write that down. Now, the color, you can take a look at it, but it looks like a brownish, beige, yellow kind of color to it. Definitely dirty. Now, when we're making observations, we want to make sure we write it in a way that people understand. So I would definitely say that this is a light beige or a yellow in there. Okay, so go ahead and write that down. As far as clarity, take a look. It's not very clear, right? It's cloudy. So let's write that down as cloudy. As far as the odor, you can't smell it. Oh, but I can, and it doesn't smell particularly nice. Notice that I'm wafting. You never want to go up to something that's unknown and just take a big whiff of it, okay? But I would say that it has like a garlicky, almost spicy kind of smell to it, whatever this dirty water is. As far as presence of oil, if you can take a look, you can see the separation between the water on the bottom and some type of oily substance on top. So the answer would be for your data table, yes, there is a presence of oil. And is there a presence of solids? You can see some of the chunks of solids right there and also at the bottom. So the answer is yes, there are still solids in there. So we've started our initial before treatment observations in our data table. Now we're going to work to our next part of the lab, which is going to be oil-water separation. After we do that, we'll then take data again. For oil-water separation, we're actually going to be using a glass funnel with a little tube at the end, okay? We're going to take advantage of the fact that oil and water are immiscible, meaning they don't like to mix together. So what I'm going to do is I'm going to pinch the bottom of this rubber tube, and to do that, I'm going to use what's called a pinch clamp. A pinch clamp is just a little piece of metal that if you open it and close it, it pinches shut. So I'm going to pinch this rubber tube shut so no liquid comes out. I'm then going to take my oil and water sample and I'm going to pour it all the way into this funnel. What I'm then going to do is give it a little bit of time, and I'm going to let the oil float to the top as the more dense water sinks to the bottom. So what I'm going to be doing is taking advantage of the difference of their densities so that eventually I can get all the oil to the top and physically separate the water towards the bottom. I'll then be able to let out the water from the bottom and keep the oil behind. That's the goal. So we're going to give this a few minutes to set up and sit so we can try to separate these as best as possible. All right, we're back, and now that we've let this set up, it's probably hard to see from here, but at the very top there's a thin layer of oil and like bubble globules of oil, and underneath is still the dirty water. Now, by no means is this water clean, but we now have taken advantage of the oil rising to the top. So what I'm going to do is I'm going to take my ring stand and raise up my funnel a little bit. I'm then going to put a clean beaker of water underneath here, and I'm going to pinch shut and unclamp this. What I'm going to do is slowly let out the water and drain it out, but as soon as I get towards the bottom here with the oil, I'm gonna pinch it shut and separate the oil out. So that's the whole idea of this physical separation. So you can see I'm gonna slowly let the water through, it's draining in here. But while I'm doing that, I'm keeping an eye on where my oil layer is. I don't wanna let that out into my water sample. So I'm gonna slowly drain, slowly drain, slowly drain. And now I'm getting towards this layer of oil. So I'm gonna be really careful not to get any of the oil in there. All right, and now you can see the little globules or little like spheres or circles of oil. I don't want that. So I'm gonna take another beaker and I'm gonna empty that oil out into another container. Now, by doing that, we now have a slightly cleaner sample of water, okay? Because we got rid of the oil through physical separation. Remember, in a heterogeneous mixture, there's just a bunch of different things mixed together, and you can physically separate them in order to make something, more pure or by itself. So we did a physical separation by taking out the oil. We didn't use a chemical reaction or anything crazy. We just used their densities to separate them out. And physical properties fall under things like density. So that was an easy way to figure that out. All right, I'm gonna clean this part up and eventually distribute this slightly cleaner water back into a clean graduated cylinder so that we can take our next data point, which is on how much water is left. So stay tuned. All right, so we are back. We cleaned out our graduated cylinder, and now I'm taking the slightly cleaner water. We got rid of the oil, it looks like, but we're gonna see how much volume of that water is left. And ooh, look it, I already accidentally separated out some of the solids as well. So we'll use that to our advantage since we're trying to clean this water. But here we go. If I read this Erlenmeyer flask, sorry, but this graduated cylinder, it looks like we have 89 milliliters of the liquid left. So go ahead and write that down under after oil-water separation. There's 89 milliliters left. Now the color looks still about the same, doesn't it? It's still that yellowish, brownish beige color. As far as clarity, it still looks pretty cloudy to me, so nothing has improved with that. Odor-wise, surprisingly, there's actually a lot less odor. It's not as strong. There's still like a spicy, garlicky smell to it, but not nearly the smell that it used to have, which is nice. As far as the oil, we don't really have that oil layer anymore, which is a good thing. So we got rid of the oil layer. So in presence of oil, you can now put no under your data table. And presence of solid, yeah, there still are some chunks of solid in there and that. So we're not quite clear of that. But we did remove some of them as well. So that was kind of a nice touch. All right, so now that we're on this part, we've got the data for after oil-water separation. We're gonna move on to something called sand filtration, which is another physical separation. We're gonna have sand and gravel, and we're going to actually be able to pour the liquid through and like gravity pull the liquid down through sand and gravel, and all these little chunks and particles and maybe even some leftover oils that we have in there are gonna stick to the sand and gravel, and hopefully more of the water will come out. So we'll set up that apparatus in just a second, and we'll let that go and see how that helps our physical separation lab. So now I have a container of gravel and sand, and what I'm going to do is take a simple styrofoam cup, and I'm going to put a layer of gravel at the bottom of my cup. You may be wondering, what's gravel gonna do? You can see the gravel inside of there, all right? I'm then going to take spoonfuls of sand, which is a lot finer. I'm gonna take 2 scoops of sand, okay? I'm then also going to get a little bit of water to moisten it so that this kind of sticks together, so that when we pour our water sample through, all right, we won't get all that liquid just stuck to the sand. So give me one moment. I'm gonna get a little bit of water on this and we'll be good. Let's take a little bit of water and we're just going to wet the sand just a little bit. There we go. By just making it a little bit wet, it's going to be more likely that we'll let the water that we are using run through. Okay, so it's just slightly have a little moisture in there. Now, how is this going to work? Well, we want our nice clean beaker. We're gonna put this on top and pour the liquid into the cup, but it will just sit in the cup if we do that. So what we're going to do is we're going to poke a couple small tiny holes in the bottom of this styrofoam cup. And by doing that, gravity will slowly start to pull the water out from the cup. So now we have our layer of gravel, layer of sand, and some holes at the bottom, and I'm going to slowly pour our dirty water into this sand trap. And you can start to see, hopefully on the bottom a little bit, some of the water coming through. Now what this sand and gravel filtration is going to do, hopefully you can see that the water's coming through. Even though it looks brown still in that, it's slowly starting to pull out the little pieces of solids. So any of those little chunks that we saw inside of that liquid, as gravity pulls the water down, some of those chunks are going to stick to the sand and gravel, and then just liquid comes out. So in the end, hopefully we have no longer any chunks left. Maybe a few little grains of sand, but none of these unidentified chunks, whatever they are. They're black and brown in that. So we're going to let this sit for about 5-10 minutes and let this naturally settle out so that we can strain this solution so that we end up with just some slightly cleaner water. So we'll give that a few minutes and then we'll go from there. And we are back, and as you can see, our sand and gravel filtration has let out all of our liquid water to the bottom, but all these little chunks that we had earlier, you'll see are missing. So I'm going to move this over to here, and let's measure out how much water we actually have left. So we're going to fill up our graduated cylinder, and when we measure our graduated cylinder, we always want to read it at eye level. And we are now at 80 milliliters. So we went down a few milliliters, which is natural. When we physically separate things out, we're going to take away some of the volume. But now after the sand filtration, the volume is 80 milliliters. Let's take a look at that color. Still pretty much similar, that yellowish brown color. What about clarity? I would say it's still pretty cloudy too. So cloudy is definitely a good answer. As far as odor, ooh, there's even less odor. There's a slight small odor, but not like it used to be. It's much better. The presence of oil, there's still no oil in our sample now that we've taken it out from earlier in our first step. And we have no solids either. So now if under presence of solids in your data table, you can say no as well. So we're doing good. We've knocked out solids, and we've knocked out some of the odor, and we've knocked out the oil. Let's see if we can clarify this, meaning that we can get this a little clearer so that it doesn't have a color to it, maybe get rid of an odor in that. And to do that, the key ingredient is going to be charcoal. So we're going to actually swirl this around with charcoal, mix it up good. Charcoal is good at adsorption, where things that are chemicals that have a scent to them or that tend to make liquids cloudy will actually stick to the charcoal. Once those objects are stuck to the charcoal, then we'll be able to strain or filter those out through a very fine filter. And then from there, we should have a lot cleaner water. So let's take a look at that by setting up this charcoal absorption setup. So to do this charcoal absorption setup, I'm going to take our black charcoal powder here. It's very fine. Put about a scoop and a half. All right. And then I'm going to fold this paper towel and slide it in to this Erlenmeyer flask. Now this is the same glass as a beaker, but an Erlenmeyer flask has a different shape to it. So keep that in mind. This is a beaker. This is an Erlenmeyer flask. So let's put this charcoal into the Erlenmeyer flask. Nice. Okay, if we didn't make too big of a mess, that's great. Now we have our black charcoal in there. And now I'm going to take our water sample and I'm going to put it inside the charcoal. Now you might be thinking, wait a minute, we're supposed to be cleaning this. This doesn't look any cleaner. Now the liquid is black. Well, that's true, but we're going to stop at the top. We're actually going to swirl this around for a good couple of minutes. By doing that, all those little things that are floating in the water that are impurities, the things that are making it smell. It kind of smelled strangely like spicy or garlicky something. I don't know what it was. Some of the leftover tiny microscopic oils maybe. The things that are potentially making it cloudy. All of those little particles can start sticking to the charcoal. Charcoal naturally absorbs things, okay? From there, we're going to clean this water out then through filtration. And to do that, notice I'm still shaking it, trying to interact the charcoal with the impurities. We're gonna take filter paper. If you think of how coffee works, you put a coffee filter down, you pour hot water over the coffee, and what comes out? The coffee grounds stay behind in the filter, and the liquid comes through, so you get your delicious hot cup of coffee. All right? Well, that's what we're going to do, but with science filter paper. So I'm going to shake this a little bit more, and I'm going to set up my filtration system, and we can go from there. But let's take a break so you don't have to watch me shaking this for a couple minutes. So we've shaken our water, I think, enough. So I'm going to show you how to set up a little filter paper action here. So when I have these white circular filter papers, I'm going to fold it in half like a taco. And then I'm going to fold it in half again, to make it look like a slice of pizza. Then I'm going to fold it in half again to make it look more like an ice cream cone. But when I unfold that, it's now made these natural edges that can accidentally fold over each other to make this round cone-like shape. So if you mess with it enough, you're going to see that it's going to fit right into our funnel nicely right there. Okay? Now what you don't see maybe at the bottom here is that I have a nice clean rubber tube coming from the funnel, and I have a nice clean beaker. So what I'm going to do is I'm going to put my funnel up high, and then I'm going to slowly pour this thick black water through this filter paper. Now if I pour it carefully, the filter paper should hold behind all of the charcoal and all of the impurities that stuck to the charcoal, and nice, clean, clear water should come out. I guess we'll see though. Let's go ahead and check. So I'm gonna actually angle down the camera, and we'll see if the water that comes out is clear. So I'm gonna pour this into the filter paper, and it's coming out thick black, but let's see what comes out towards the bottom. Ah, awesome. If you can see, the water's already trickling down, and it's probably hard for you to see because it's clear. That's right. Our water is coming out crystal clear. The charcoal did a great job of sticking to the impurities, but now that filter paper, gravity's pulling the water down, but the filter paper won't let the charcoal through. Just like a coffee filter. The coffee grounds can't go through, just the liquid water can. It's another form of physical separation. So this is pretty awesome, and when we do this in class, a lot of students are shocked how clean the water's coming out. They don't believe it. But again, if you ever make coffee, you've seen this phenomenon before. It's just filtration, and you're using gravity to pull the liquid down. All right, this is going to take a few minutes because this filter is so fine. So we're going to give this a few minutes to let the water leak out. And once we do, we'll finish up our data table, answering questions like the volume, the color, the clarity, and that. So take a quick break here. I'm going to turn off the camera, and we'll come back when we're ready to rock with our final sample. So we're back, and we have officially filtered out the charcoal. Take a look at that. The filter paper left all that charcoal behind, and look at our clear water sample. Wow. Awesome. So it's amazing what physical separation can do to clean water. So let's do a couple last pieces of data. I'm going to measure the final volume in my graduated cylinder. And if I look at it eye level, it looks like it's at 65 milliliters. So quite a bit of the liquid was lost in these final few steps. We started with 100 milliliters, and now we have 65 milliliters of water left. Let's take a look at that color. No longer cloudy, brown, or yellow. That's a nice clear color, right? Also clarity. No longer yellow or brown for clarity. This is nice and clear. So clarity is clear, all right? Not cloudy. Odor. There's actually no smell left to it. The charcoal did a great job of removing the smell. There's no oil in it. It's nice and clear, and there's no solids either. So this is nice and clean. Now, a common question is, well, can we drink it? I wouldn't in a lab because of all this different glassware, we never know where this came from. Also, one thing we didn't account for technically is bacteria growth. How old is this water? Is there bacteria? Physical separation can't necessarily separate out the bacteria that could eventually make you sick. So, and always in labs, we're not eating or anything like that. But if you were on a deserted island and somehow had all this stuff, you'd have a lot cleaner water than you started with. I would probably boil it first to try to kill off any germs, but then I'd be pretty confident that it would be pretty clean water. Nice job following along, and now you have your data table, and you can answer the remaining questions that follow up with this lab. So thanks for sticking with us, Science fam. Best of luck with the rest of the lab, and let us know if you have any questions. Be well.